Hello everybody, I'm Nicholas Blanco and this is for exam 1, question 6 for Dr. Jafar. So we need to find the integral of 81 plus x squared. So in order to do this, we can use a u substitution since we have one x squared and then one regular x. So in order to solve for this, we need to perform a integral substitution. So since the constant is added to x squared, then the substitution we would use is x equaling 9, a being the constant, 9 being the constant, tangent theta, and then the derivative of which would be 9 secant theta d theta. So you'll see in a second why we used this identity to solve for this function. So we'll perform the substitution. 81 plus 9 tan theta, squared of course, all square rooted over 9 tan theta, times, since dx is over here, we must include it over here, so d theta, or dx, is equivalent to 9 secant squared theta d theta. So now we're solving for this integral. So first step would be to take out this 9. So that would give us 81 that would give us 9. Since we're taking it out of a square root, we'd have to square root it ourselves. 1 plus tan square theta over 9 theta, 9 secant squared theta d theta. So since 1 plus theta squared is an identity, so we can actually replace this as secant squared theta square root over 9 tan theta times 9 times 9 secant squared theta d theta. So now at this point we can square root the secant, and that will just be secant times, since this is secant squared, we can perform an identity. So this would be 9 secant times 9 times tangent squared theta plus 1 all over 9 theta tangent. And can't forget to include our d theta. Okay, so now that we're at this point, we can start distributing all the information. So that would give us 9 secant times tangent squared, which would be, or actually we can distribute the tangent first. So this would be 9 theta squared theta, and we divide by tangent, and that would just cancel out this, plus 1 over tangent theta, all multiplied by secant theta. So now we can distribute the secant, and distributing the secant, this is 9 secant, can't forget to include the 9 secant, this distribution, also can't forget to include the 9, so it'd be 9 tangent divided by tangent. We can actually cancel out the 9 on both of these. So that would just give us 9 secant theta times, not squared, 9 secant theta times tan squared theta plus secant theta over tan theta. And we can rewrite this, microphone focus, as 1 over cosine or hold on. This would be 1 over cosine times cosine over sine theta. Ignore the noise in the background. That would just give us secant, or cosine, no. Wow, I'm blanking on the word for that. Cosecant theta, excuse me, and since we multiplied this out, it would give us 9 secant theta squared. I mean, canceling out this square. So deriving this would give us 9 secant theta plus cosecant theta integrated. Apologies for the unfocusing on my camera, I'm trying my best. So now, solving for the integral would give us 9 secant theta plus ln, that might be a little bit better way of positioning it, 9, oh, can't forget, this is 9 secant, can't forget to include our constant, carry that down. So this would give us ln of 9 cosecant plus 9 cotangent, absolute value. And now that we have solved for our integral, the last step would be to reintroduce our substitution. So we can rewrite it up here as 9 secant theta plus ln, absolute value of 9 cosecant 9 cotangent theta. Okay. Now then, we can create a relationship between the substitution. So tan x theta is equal to x over 9. So x would be opposite, 9 would be adjacent, and then x squared plus 9 squared would be our hypotenuse. So in order to perform this substitution, we would say it'd be 9 times secant, which secant is 1 over cosine. So cosine being our adjacent, our adjacent over our hypotenuse, and we can just flip that to be x plus 9 squared over 9 plus our cosecant, which is the ln of 9 times our opposite over adjacent would be our sine, so then for cosecant it'd be our hypotenuse over our opposite, which would be 9 times square root of x plus 9 squared over x plus our cotangent, which is just our adjacent over our opposite, which would be 9 over x, giving us our final solution of 9, canceling out this 9 would get canceled out. So we're giving us our final solution of x plus 9 squared plus ln of 9 x plus 9 over x plus 9 over x as our final answer, and just to include it, plus c. And that would be our final answer.